the previous lecture we have discussed about digital electronic basics, the what is meant by number system and the classification of number system, how the number system is classified. The number system is classified with radix R and BCD codes. In radix R, binary number system, decimal number system, octal number system, hexadecimal system. In that lecture we see what is meant by binary number system, octal, hexa and decimal. In this lecture we will see decimal to binary conversion, from one number to another number conversion. Decimal to binary conversion. Decimal, the number with radix 10. The number system with radix 10 is known as decimal number system. The number system with radix 2 is known as binary number system. How to convert a decimal number to a binary number? Radix 10 to radix 2. Decimal to any. To convert a decimal number to any number, we have a definition. To convert decimal number to any number, divide the integer part. The number will have an integer part and then fraction part. Divide the integer part repeatedly and multiply the fractional part repeatedly with required base. We have to divide the integer part repeatedly and multiply the fraction part repeatedly with required base. We will have a clear explanation with a problem. The given problem is 38.15. It is in decimal number system. We have to convert it into radix 2, that is binary number system. To convert, how to convert to any number, decimal to any number? Let us see decimal to binary number. Decimal to binary number, divide the integer part repeatedly. Divide the integer part repeatedly. It is a given number. In the given number, 38 is the integer part. It is the number which is before the point, decimal point. It is the integer part. And the number which is after the decimal point. After the decimal point is fractional part. In the definition given is, we have to divide the integer part. Divide the integer part repeatedly and multiply the fraction part repeatedly with required base. Divide the integer part repeatedly with 2. Here the base is 2. We have to divide 38 repeatedly with 2. We will get the integer in binary format. Thirty-eight 0. It's a simple division. 19 2s are 38. We have to place the quotient here. It is a repeated division. We have to place the quotient here and remainder take it out, and it is the equivalent binary number. Again divide it with 2. 9 2s are 18 and the remainder will be 1. Divide it with 2. It will be 4 and the remainder will be 1. Divide it with 2. It will be 2. The remainder will be 0. 2. The remainder will be 1. When should we have to stop this division? We have to stop this division when the divisor 2 is less than when the divisor 2 is greater than the dividend. When this dividend 38 becomes 19, 9, 4, 2 and 1. When it becomes less than the divisor, if the divisor is 2, when it becomes less than the divisor, we have to stop the division and take this bit out. And the equivalent binary number for 38 integer part will be from bottom to top. 10110 10110. It is the integer part. 38. The equivalent 38 is 10110. To find the fractional part, to find the binary equivalent of fractional part, multiply the fractional part repeatedly with required base 2. We have to multiply the fractional part repeatedly with 2. The fractional part is 0.15. 0.15 into 2. It will be 0.30. We have to take out the fraction part again. 0.15 into 2, the answer will be 0.30. In the answer we have to take out the fraction part. .3 and again multiply it with 2 and it will be 0.6. Again we have to take the fraction part and again multiply it with 2 and we have to take out the decimal part out. Here the value is 1 and here the value is 0. Here the value will be also 0. Again multiply 0.6 with 2. It will be 1.2. Take out the decimal part 1 and take out the fraction part here. 0.2 into 2, it will be 0.4. The decimal part and again the fraction part into multiplication. 0.4 into 2, it will be 0.8. Take out the decimal part and fraction part into again multiplication. 1.6. How long we should continue the division, multiplication? How long? We multiplied up to 1, 2, 3, 4, 5, 6. We multiplied up to 6 steps we made multiplication. When to stop this multiplication? We have to stop the multiplication when, say, next multiplication 0.6 into 2 equal to 1.2. The number 0.6 into 2 is repeated. Here we done the multiplication of 0.6 into 2 and the number 0.6 into 2 and the multiplication is repeated again. When the multiplication is repeated, we have to stop the multiplication. Why we stopped here? Because in fractional value that will be 0.33333. These all threes were same. We used to consider it as 0.323. And the same process on the same method will apply to here, where we round off to 0.323, where after 0.323 it all have equal values of 3. We round it as 0.323. And here also to prevent these type of values or exceeding values 0.3333, we stop multiplication here. And the equivalent value will be, we will take the binary value from top to bottom. It is the reverse case when compared to division. From top to bottom the value will be 001101. Sorry, the value is 0. 001001. And the equivalent value and the equivalent binary value of 38.15 decimal number is 11101110001001.